Okay, 5.7, solving rational equations. Are you ready? In 5, 4, 3, 2, 1. The first thing I need you to do is to actually be quiet. That's what that meant. Alright, now I'm starting over so I can cut that part of my video. So we're starting 5.7, solving rational equations. First thing we need to talk about is what is the difference between an equation and an expression? Anybody know?
Oh.
Dylan.
The equation has an equal sign.
Yep. An equation has an equal sign. And because it has that equal sign in there, we can solve it. Usually. Okay? What's an expression? That's what we've been working with. Now I don't know how to spell it all of a sudden.
It's S-S-I-O-N.
That's what I thought, but my brain suddenly didn't want to process it. Okay, so expression. What's an expression? How is it different from an equation? There's no equal sign, and therefore you cannot solve it, but you can simplify it usually, or you can add it to other stuff, or you can multiply it times other stuff. You can work with it, but you can't solve it. Okay? So sometimes we can simplify expressions, but we can never solve expressions because we don't know what they're equal to. Okay? So that's just a quick little review of 2 vocabulary words that I need to put on our word wall. Okay. When we solve rational equations, one of the easiest ways to solve rational equations is if you only have a single fraction on each side. We're going to call this method number 1. You cross multiply. How many of you have ever cross multiplied anything before? Only 2 of you? 3? 4? Okay. Cross multiply, but that only works when you have a single fraction on each side. On each side of the equal sign. Okay? Let's do an example of method number 1. Alright. Let's do 3 over 2x minus 3 equals 1 over 5 minus 2x. I'm going to move this whole thing up so we can see it a lot better. Okay, so notice how I have 1 fraction over here equals 1 fraction over there. Technically they're rational expressions, not fractions, but it's just easier to say that. Anyway, so cross multiply, what does that mean I can do? There's a property that says I can cross multiply fractions and get rid of the fractions, right? So I can multiply this numerator with that denominator, and that'll be one side of my equation. And then I can multiply this numerator and denominator, and that'll be the other side of my equation, and I can just set them equal to each other. Okay? So let's do it. Does it matter which side the stuff goes on? No, it doesn't. So you could put these over here or over there. You could put these over here or over there. I think I do it different ways, different times. I never really pay attention to how I'm writing it down. I just kind of go for it. Okay. So I'm going to start by multiplying this numerator and that denominator. So I go 3 times 5. What's 3 times 5? In fact, I'll just kind of write this out first. 3 times 5 minus 2x equals 1 times 2x minus 3. So let's multiply this out. So someone said it's 15. And then what's 3 times negative 2? Negative 6. Good. And then 1 times 2, 2x, right? And then 1 times negative 3 is negative 3. Look, we got rid of the fractions. No, it's just a linear equation that you hopefully learned to solve in junior high. Okay, what do we do when we're solving a linear equation like this? We want to get the x's together on one side and the others together on the other side. Okay, so we can add 6x to 2x, so we have 15 equals 8x minus 3. Now what? Sure, let's add the 3. So we have 18 equals 8x. Divide by 8. Great idea. When you divide by 8, 8 divided by 8 is 1. So that basically cancels that out. And then we have 18 divided by 8, which doesn't go evenly, but it's not terrible. So 18 divided by 8 would be like 9/4. Or if you put it in a calculator, what do you get? 2.25?
Yeah, 2.25. Exactly.
So x equals 2.25. We found a value for x. Yay! Okay, so now we have to go back to section 5.1 and remember something we learned. I know, 5.1, everybody hated it, but now it's coming to be important again.
5.1.
The very first assignment we did for 5.1, Delvis, did I suddenly say talk? No, I didn't. Okay, so the very first assignment we did for 5.1, we learned about excluded values. We learned that some numbers make the denominator 0, and that's not okay. So we actually have to check our answer to see if it's an excluded value.
So you just plug that.
Plug it into X.
You don't have to plug it into every x. Oh, and although in this problem you do. You don't have to plug it into any of the x's in numerators, but notice how there's no x's in the numerators. So we're just going to plug it into this x and see if we get 0. And then we're going to plug it into that x and see if we get 0. So if we plug it in here, we have 2 times 2.25, which is 4.5. And what is 4.5 minus 3? 1.5. I don't even really care that it's 1.5. All that I care about is it's not 0. Yay, it works. Okay, what do we do here? 5 minus 2 times 2.25. So that one's 4.5 again. What's 5 minus 4.5? 0.5, which is not 0. It's perfectly fine to divide by numbers that are not 0. Okay? So guess what? It works! And there's our solution, and we're done with that problem. Will you guys try one for me? Actually, we'll just do one more together because this one's a little bit weird. 4 over x equals x over 9. Go ahead and cross multiply it for me and tell me what you get.
Oh, I know what to do.
What do you get when you cross multiply it? Dylan.
You get 36 and x squared.
So x squared equals 36. Okay, there's 2 different ways to solve this. Typically when you have a quadratic, that means we have a squared, degree 2. Typically when you have a quadratic, you're going to get everything on one side to solve it, and then you either factor or use quadratic formula. This one, though, we actually have a choice where we could just take the square root of both sides. The tricky thing about that is that you have to remember when you do a square root that there's a positive answer and a negative answer. So I think it might actually be easier if we move the 36 over here. And then what does this thing factor into? What does this factor into? X minus 6x plus 6. So what are the answers?
Positive 6 and negative 6.
Positive 6 and negative 6. Now what do we have to do? We have to check them. Do we need to plug them into that x there? No, because it's in a numerator. So we just check them by plugging them in here. So plug in a 6, we can divide by 6. Plug in a negative 6, it's just fine to divide by negative 6. Neither of them is 0. And they are good. We are done. Okay? Now there's a harder method. This seems really easy, right?
Yeah.
But there's something a little harder that I want you to learn.
Oh, man.
Let me just stop my video.